Hello everyone, today we will be learning about vectors which are very important to learn about motion in 2 and 3 dimensions. Now what are vectors? There are certain physical quantities in which it is not sufficient to specify its magnitude only. It is of importance that we specify its direction also. For example, when an object is moving with a velocity v, we need to specify the direction of its motion, whether it is moving left or right, whether it is moving north or south or northeast, etc. Thus, a vector has a magnitude as well as direction, and a vector quantity is thus a quantity that has both magnitude as well as direction. For example, displacement, velocity, acceleration, force, etc. In contrast to vectors, there are certain quantities which do not involve directions. These are called scalars, for example, temperature, pressure, etc. Now a vector is shown by drawing a ray. The direction of the arrow shows the direction of the vector, and the length of the ray shows the magnitude of the vector. Thus AB here is a vector. Thus AB represents a vector. The magnitude of AB is its length. The direction of AB is shown by the direction of the arrow. Vector BA is equal to minus of vector AB. That is, the negative vector of AB is shown by a vector having direction opposite to the direction of AB. Therefore, AB is equal to minus of BA, or BA is equal to minus of AB. Now there are certain mathematical operations that can be performed on vectors. Like vectors can be added, they can be subtracted, they can be multiplied, etc. To add two vectors A and B, we place vector B on the tip of vector A, and then we draw a vector from the tail of A to the tip of B. This vector is called A plus B. Thus, vector A plus B is a vector from the tail of A to the tip of B. Now, vector addition is commutative, that is, A plus B is equal to B plus A. This can be shown by placing vector A on the tip of vector B. Here we have placed vector A on the tip of vector B, and then we draw a vector from the tail of B to the tip of A. We can see that these two vectors are exactly the same. Therefore, A plus B is equal to B plus A. Now vector addition is also associative, that is, we can add a vector C to the resultant of A plus B, and this will be equal to the addition of vector A to the resultant of B plus C. This can be shown like this. We have a vector A, then we have vector B. Vector A plus B will be vector from the tail of A to the tip of B, that is, vector A plus B is from tail of A to the tip of B. Then we add the vector C to A plus B, and this will be a vector from the tail of A plus B to the tip of C. Therefore, this purple color vector will be A plus B plus C. Now to add B and C, we draw a vector from the tail of B to the tip of C. This vector is B plus C. Then to add vector A to B plus C, we draw a vector from the tail of A to the tip of B plus C, and this is equal to A plus B plus C. We see that these two vectors are same, thus A plus B added to C is equal to A added to resultant of B plus C. Thus vector addition is associative. To perform difference of vectors, we simply add the negative vector to the another vector. That is, if we want to find out A minus B, we simply add negative vector b to vector a. Now that we have seen how to draw vectors, we will now learn how to write them. Vectors are written in terms of its components. A component of a vector is the projection of the vector on an axis. It requires that the vectors be placed on a rectangular coordinates or xy coordinates. Thus, to determine the components of a vector, we place the vector in a xy coordinate plane. Then we draw perpendicular lines from the tail and tip of the vector to the x-axis. The x component of the vector will be horizontal line between these two perpendicular lines. Thus, ax will be the x component of the vector A. Similarly, to determine the y component of vector A, we draw perpendicular lines to y-axis from the tail and tip of the vector A. The vertical line between these two perpendicular lines is the y component of vector A. If the vector A makes an angle theta with the x-axis, we can determine ax and yx as ax is equal to a cos theta and ay is equal to a sin theta. The magnitude of the vector A can be written in terms of the components, like A is equal to a square root of a square plus a square root of ax square plus ay square. The orientation angle of the vector can be determined as theta equal to tan inverse ay by ax. We can now obtain components of vectors in different directions. We will now learn to use them to represent original vectors in terms of these components. This can be done by using unit vectors. Unit vectors are vectors whose magnitude is unity and points to a particular direction. It lacks both dimension and unit. The unit vectors in x, y, and z directions can be written as I hat, j hat, and k hat respectively. A vector can now therefore be written in terms of its component and unit vectors as a vector equal to ax times I hat plus ay times j hat plus az times k hat. Writing vectors in terms of its components makes it easier to perform algebraic operations on vectors. For addition and subtraction, components of vectors pointing in the same directions can now be added or subtracted. For example, if A is a vector having components ax, ay, and az, and B is a vector having components bx, by, and bz in x and y and z directions, the unit vectors are I, j, k. We can now find A vector plus B vector as ax plus bx times I hat plus ay plus by times j hat plus az plus bz times k hat. Similarly, we can find difference of vectors as ax minus bxi plus ay minus byj plus az minus bzk. Now, multiplication by a scalar simply changes the magnitude of each vector component by a factor equal to that of the scalar quantity. For example, if A is a vector pointing in a certain direction, if we multiply this vector by a scalar lambda, it will increase the magnitude of the vector and the new magnitude will be lambda A, and the direction of the vector will be the same as A. Writing it in terms of components, A is a vector having components ax, ay, and az and unit vectors I, j, k. Then lambda A will be equal to lambda axi plus lambda ayj plus lambda azk. The magnitude of the vector lambda A will be equal to lambda times magnitude of vector A. That's all for this lecture. I hope you like it.